I'd like to thank everybody for joining us today. This is URISA's monthly Texas Speaker Series, and it is June 16th, 2020. We've got a great one today where our presenter, Richard Kelly, will be going over the current state of 911 GIS and where we should go with it and the importance of that in the future. Richard has 25 years of public and private sector GIS experience and is currently the acting senior GIS solutions engineer for a leading national 911 CPE provider. He currently serves as vice president of geospatial solutions with 911 Data Master. That was a previous position he had held, and has designed and patented 911 applications and processes, and also is involved with both NENA and APCO standard working groups and serves on NENA's liaison to NSGIC. And so with that, Richard, I'd like to go ahead and throw the ball in your court and you can take it away.
Thank you, sir. Hey, good morning, everybody, and afternoon for some of you. It's a pleasure to be able to speak with you today. Hope everybody can hear me okay. What I want to do for all of you in the audience, you'll have a broad range of backgrounds, is try to, in the short time we have together, impart to you the critical nature of spatial data, GIS data. I use the term spatial to really emphasize to those who don't work with GIS as much the nature of the data as opposed to just a regular old tabular database, a spreadsheet, schemas, though we'll talk about that today as well. The content I'm going to provide and the information is going to come from the National Emergency Number Association. NENA, as you heard from my brief bio, is something I've been working with and many of you have been either aware of or worked with for a number of years. It has about 15,000 members nationwide, and they are the organization responsible for putting together how 911 calls are delivered and the technology and infrastructure to facilitate that. I also work with the APCO, and APCO is really concerned with the operations within the 911 center and dispatch and what have you. So we're going to blend some information here to give you a broader picture of how this GIS or spatial data works. What we've done on the presentation today, and I'm certainly not going to be the expert on all aspects of this, it's too big a topic. What I can tell you is we are right now undergoing a complete paradigm shift, and I mean that in every sense of that definition, that the way we do business in 911 today, right now, in your hometown, your county, is that we're going to have older technology based on copper lines and underground communication systems slowly being replaced with a more current IP-based technology. We'll get into that a little bit today, but we'll break this up into sections, and we'll start today with where we are. And you'll see these headers in each of the sections. When we go through this, there's a big future in 911 public safety, and particularly in GIS and data development. There's just not enough expertise out there, and it will grow to the point where we have to question whether or not GIS is a 24/7, 365 job, not just a 9-to-5er, but do we need to have people on call that can come in and work on servers or work on database recovery in the midst of active 911 call taking? So on screen, you have a diagram that is the traditional way we handle 911 calls today. This is available on Wikipedia. I decided not to rebuild it because it was really nice. It really handles it. What you've got in the blue above is going to be how we typically handle what we call landline calls. You know, the plug in the wall, what we've been doing for decades. Most of us on the call, myself included, have moved away from that and work with wireless calls. But at the top, that blue box, you're going to see a database box that says ALI, Automatic Location Identification, and an MSAG, Mastery Address Guide. Those database components drive everything about 911 today. When you subscribe to your landline phone or your grandmother or mom or whoever, they have to pay a bill, and part of that bill, a small fee, goes into maintaining that along with their customer address. That, for decades, has made up the basis by which that database for public safety has been formed and accessed by call taking. Now, for wireless, it's kind of the same deal, but when you register, you have a phone number, certainly that's delivered, but it comes away from a cell tower or sector, and there's a degree of refinement of where you are on your cell phone based on the capabilities of the phone itself and the network you're calling from. Both of these go to this one little box in the middle, the selective router box. I've got a red box around it. If you think about the calls today, we've gotten away, I guess in 10 or 15 years, from the preponderance being what we call landline, the top blue box, to wireless, or even voice over IP, the VoIP calls, 90% or more in most locations. That's a huge change. Now, with that change, some of that older technology has to be retrofitted with newer technology, and we have some phrases we have to keep in mind. You don't have to write anything down from this presentation, by the way. You're all welcome to have it. I've already provided it to Dylan here at URISA, and you'll be able, I think, Dylan, to download it sometime after the call.
Yes, we'll put it up on our website.
Great. And this is all public information, so it's good stuff to have. You've got to know some terms as we go into 911 technology to get to the GIS part. One is the public safety answering point. You're going to hear me rattle on about PSAP, PSAP, PSAP. That's just a generic term for the 911 call taking centers. From the APCO side, we call it the Emergency Communication Center, and there are other terms used in the industry. But for the purpose of today, we'll just refer to it as the PSAP. I already mentioned the automatic location identification, the ALI. Think of that as your individual telephone number, address, and everything goes with that. The Master Tree Address Guide is a listing of all the individual streets, the lowest and the highest number, and who the responders, through usually an ESN, emergency service number, who the responders should be for that particular area. And we won't get in all the details. I'm giving you real generalizations. But when we take this world and we look at the future, we have to learn new words. And the 4 primary words, and you'll see all these in red here, I've tried to highlight them in red throughout the presentation, is the PIDF flow. The weirdest sounding thing, the presence, information, data, format, location, object, that's going to be our future ALI replacement, if you will. It's going to deliver who you are calling from, who you are, where you're calling from, in that format. It's kind of like what the ALI does today. It'll have your location, and everything will be based on finding what's in that file. The emergency call routing function, or ECRF, that's going to be a box that's going to have software in it, map data, that's going to figure out, using the information, the PIDF flow, where you are, and more importantly, where to send you. Today, in that previous diagram from Google where we showed how landline and wireless works, there's pretty much dedicated communication. The call's going to go right to a call taker, and then they'll be able to act on it from there. What's important to understand in Next Generation 911 is that the ECRF, the emergency call routing function, you don't get to a 911 call taker, a human, until that system has performed its function. And we'll get into that in a minute. The 2 terms that we're going to change, because 911 loves to change terms, we're not going to use landline, we're not going to use wireless anymore. The new term for landline would be a civic location, because it's much more than just a landline. And geodetic would be the new reference for a wireless type call, which is based on coordinates. Here's your diagram you got to memorize. This is kind of what the next generation world was supposed to be. We don't need to know all of that. Here's our selective router. That's the old school database that the service providers had, which had all your information of who you are, where you live, who the responders would be, all of that. What we're going to do is break that down into parts in the next gen future. We're going to have emergency call routing functions we've talked about and databases for them. We're going to have other components, which we'll get into a little bit in this diagram. But what I wanted to really get to you, get across to you, is in this one diagram, how the call is going to get from your device to the 911 center, be it a PSAP or ECC. What do we do? Well, the first thing is we got to have some basic data. You have to have road center lines. These are all required layers in the future of 911. So every county and city has to build a road centerline network. Now, it can come from a Department of Transportation, it can come from Census, it can come from whatever the county is using for road and bridge work. Wherever it comes from, if you don't already have it 911 centers, and most do, that has to be following a certain guidelines of how it's built. So the road center lines are a critical layer. Site structure address points, which are better than road center lines at refined locations, are also a required layer. The PSAP boundary, or ECC, the boundary by which those call operations are handled, are very important, because if a wireless call or landline call is determined to fall within that boundary determines which center the call goes to, all based on GIS, and it all happens in this box, the ECRF box. And we need emergency service boundaries, the responders, and provisioning. Now, in this, your data fills in this box at the top, the ECRF. When your call comes in, it's going to be using our friend the PIDF flow, which is the alley replacement, it's going to have your location and send it that ECRF. And it's going to, based on your map data, which 9-1 center do I go to? Well, that location information gets where it needs to go to and is sent back to that location. That's the simplicity of it. We won't spend a lot today, but it's all based on your emergency call routing function, which we mentioned earlier on. Now, clear your mind for a second. Let's talk about how that call routing happens. It's not even the routing, it's the determination. How do we tell our routing technology where to go? When we get a geodetic location, remember that's an X and Y, we got to start with the boundaries. In this case, there's that PSAP acronym again, Public Safety Answering Point. I have a simple example where I had two. Now, if I have a cell phone call, the system, the ECRF, the box, there's no body involved. It's doing it all on its own. It has to figure out where that call is located. Is it PSAP A or is it PSAP B? Once it does, there's a designator for which PSAP, how to reach out to PSAP, that this server, this ECRF, sends the call to, along with all the location information. And then we execute response operations for 911 call takers. In this next example, what we're talking about is, all right, what if I don't have the coordinates and I want to use just a regular old civic location like 105 Walnut? What do I do then? Well, if that's the case, then those roads come into their importance, and we basically can geocode along that road. For those who remember on geocoding, we're basically interpreting a number within a range of numbers in the attributes for that street, in this case Walnut. Then we do an offset, and we figure out which PSAP it falls in. Again, that sends the call to the right center. To make it even more complicated, well, that's great, Richard. We've got PSAP boundaries for wireless. We know we need the roads if we're going to do a civic location, but what if I have a problem where the road may not be enough? What if my address points are necessary? Because I may have buildings in two different jurisdictions. Like the county may have one polygon in one PSAP or response area, and the county may have another one in the city. So in this case, those buildings, those structures help, and that's where we deal with site structure address points. That's what that weird SSAP acronym is about. And then we simply go in and say, all right, which building, which have the same address, does that call need to be dealt with for routing? Now, that gets into something called dispatchable location. You've got a note here, site structure address points support dispatchable location. We won't go into that here, but that's not for dispatch operations. That is really a term that the Federal Communications Commission has designated as addresses that have subunits, like building, floor, unit, room. We'll talk a little more about this. And here we're going to start on the first poll. That was very brief, very quick, but do you understand the need for these changes in US 911 technology? That we've got to get to a point where we have to change the technology, go a new way. It's getting old. The revenues are going down. We need to basically take those selective routers, the ones in the first red box and that big old diagram I showed you from Wikipedia, and say, okay, it's time to decommission them. Does it make sense that not only are we going to be able to do that, but that we're also going to be able to have so much more data that we can squeeze into the world rather than what we dealt with ALI, which only had 512 characters. Really didn't change. Now we can deal more with video and all pictures and all kinds of formats of data if we upgrade our system.
And Richard, there's our first question in the chat from N. Polius. It's, does PDFLOW apply to all calls or is it just landline calls?
Now it'll be all calls in the future. So that PDFLOW is going to basically replace the little text file. We used to get the ALI, automatic location identification. It really came in as a text file. And here's the thing. That big diagram that I showed you at the beginning from Nina, it looked like just a whole bunch of boxes and clouds and things. Next-Gen 9-1 is predicated on one basic principle. Everything is connected to everything else. That includes databases. Well, we can't really connect the networks unless they can speak a common language. And we're working on it at the national level. But we also can't exchange data unless it's in a standardized format. We call that interoperability. So we can exchange it between cities and counties and states. Now, when we go to this next section here, we're going to talk a little bit about how do we do that. And these are fundamental next-generation 9-1 data concepts. We're going to go back to a more simplistic diagram where we've got different elements on here. Here's our friend the PSAP, our cloud. Here's the ECRF box we talked about where our map data goes, the GIS data. We have a few other things. We have local map administration here. We have, here's where the alley can come from and other versions of alley, the MSAG. Something we won't get into today, location database. Just assume this is location information. We will have the ability when we build that data, not only to have it go in from where you're building it from into the ECRF, but it can go other places. We can aggregate it at a state or national level and go through what's called a spatial interface, which we won't get into today. Think of it as a translator, right? It's like Rosetta Stone. You know, you're translating everything into a similar format to go everywhere else, and particularly out of the network to other systems. And it could be beneficial to use not only map displays, but CAD systems, mobile data terminals, merge notifications. Now, there's a lot there. What I want to tell you is the goal in NextGen, if we have the same format of the data, is the same data goes everywhere. Whatever data I'm building locally, it should go to the ECRF. It should go to my CAD or map system. It should go outside my network to other systems. That's the goal. Build it once, have it go everywhere. And there's a lot of standards that go with that. So what I put on this, think of this as your cliff notes, your cheat sheet. Excuse me, you can go in here and look at any of these funky acronyms, these letters, and say, this standard STA010 version 3 should give me some GIS perspective on any of these systems. And I've got these everywhere. If you're talking about what my GIS impact is on ALI or MSAG or LVD, STA010, that's standard, and you can look it up. These are NENA standards. We'll have this information for you. Okay, so use it as a backup when we go through this. Now, I will tell you that the largest document, I can't even say yellow pages, I don't know if nobody knows what that is anymore, and Bible gets this too wrong, but if this were the Bible or some other major book, it would be Old and New Testament. It's a huge book of standards. Right now, the version 2 was at 363 pages just a couple short years ago. We're working on version 3. I'm part of that work group. So some of the finest minds in the business are involved in leading and organizing that group. It's at 654 pages for part 1. It's 171 pages for the appendix or part 2. So unless you got extra time on your hand, I don't think any of you are going to be reviewing over 800 pages of technical documentation. So what I've done here is try to call out of it some of the things that are more applicable to what we've already talked about. There's discrepancy reports, which are going to be very important. There's how we deal with data for the ECRF, which we're talking about. The MSAG, there's a conversion service. We won't get into all these, but a couple of these we'll talk about. What I do want to bring all you GIS practitioners up to speed on is that this WGIS 84 is the format of the realm. So if you're looking at an NAD 27 or 83 datum, you know, the mathematical model that your data is based on, your local GIS, be it a transportation department or you're doing urban planning, whatever it is, everything has to be translated into or transformed into 84. And if it's going out as a data layer necessary for ECRF, it has to be converted into that format. So that introduces some of its own problems. For you, those of you who likes to be your own geodesist, you know that if you transform a data set from one datum to another, there's the potential for introducing error or problems. So this is something that we have to have some real concerns on. Dylan, how are we doing? If you've got some questions that come up, you need to stop me. You go right ahead.
Actually, we do just have one that popped up from Ramon Campos, and he was asking, how will the World 2022 projection impact that effort?
Ramon, I was trying to stay away from that. So the National Oceanic and Atmospheric Administration, NOAA for short, they have come up with a new datum. We have had NAD 83, well, since 1983. And what we're trying to do is deal in a two-dimensional world with the most accurate information possible. The World Geodetic System of 1984, that WGS 84 format was designed, it's a Cartesian coordinate system, to make sure we have consistency everywhere for the same data. That was what was decided, I think, a decade ago for the data model and for NENA interoperability. However, it has some problems in how accurate it can be, what the accuracy can be dependent upon in it, particularly when we talk about elevation and sea, which we'll talk about towards the end. NOAA came up with a highly precise model they're refining now. It's the North American Pacific Geopotential Datum 2022 that Raymond is talking about. And what that NAPGD 2022, yes, it's taken practice to get that down. That's a whole presentation in and of itself. but allows us to get the FCC to NINA and the 911 community requirement of meeting a 3-meter or less vertical accuracy component and even better horizontal, right, along the land. So vertical and along land, we really can't achieve that to that new 2022 data comes out. Specific to your question, Ramon, if that 2022 comes out, and I've been working with NINA to make them aware of that and working with NOAA on this, then we will have to revise this document, and it'll have a ripple effect on all documents in NINA at the point in time where they want to resolve changing from WGS 84 to this new NAPGD 2022, and then of course there's whatever local data, you know, for your projected coordinate system. They'll have, right now NOAA's working on state plane and other projected coordinate systems on top of that new datum. We'll all see. It's not due out for 2 more years, but we're going to watch that carefully, and we'll have other updates, probably presentations on what that means. Love that because it's all about the math. I can tell my high school teacher, yes, I know I sucked at geometry, but now I know how important it is. All right. So one of the things in that STA010 document, and this is kind of with a shock treatment, look at all the GIS layers, which I know you can't read, that they have officially defined and given them codes for. You've got everything from your obvious ones, points, police, fire, law, medical, to every kind of police and federal, ATF. You can go down here. I don't even know what a police park is or police housing. So we've got all these predetermined terms. For us, though, we're starting up in all the states and counties that are moving towards next generation. There's only a few, as we said before: roads, address points, the PSAP or communication center boundaries of jurisdiction, the fire law, and medical, and then maybe an alias table. So the question I have is, if we talk about those layers, roads, address points, you know, the boundaries for the call center, the boundaries for the responders, do you happen to know if your jurisdiction or if your county, do you have that data? Do you have the necessary data? Do you not have the data? Do you not even know? Because this is something that's going to affect every person in the United States having good data, whether they know it or not. So let us know in the poll. What do you think on that? And I'm having a nice cup of cold coffee here. Keeps us going. How are we doing, Dylan?
Oh, good. We got about half of the people responded, and I'm about to end the poll here in just a second.
Yeah. Always fun to get y'all's responses. You're not held to it. It's just interesting.
So it looks like the majority of people already have the necessary data.
Yeah, and don't feel bad if you don't or you don't know. We're going to get into that next. It's kind of important where we're going to go. Okay. So, and again, per what we listed on the agenda, we're going to go now into PSAP boundaries, responders, roads, and address points. What are these layers? Why do I care? So the key document was the NG9-1 GIS data model that outlined the schema, the database structure for the layers, and it determined which layers are necessary for 911 systems to operate in the next generation environment. The standard I put in green bold there is NINA STA006. It's at version 1.1. Just came out this spring. I think it was January, February. So you can pull that down right now. It's a PDF file. You can search for it. I've got, just type in that code. In it, we talk about PSAP boundaries and the importance of it and these other layers. What I want you to make sure you take into note now, per what Raymond just asked, is that we don't have a vertical component at this time that's dependable. And the wording on the vertical is a little fuzzy, so Noah's going to help us with that. We're in the middle of spinning up a version 2 of the data model. That work gets underway. I think it's Thursday, that group's starting. And I'll have a plug at the end if you guys want to get involved with NINA. Within the data model, here's my plea to all of you GIS professionals. The #1 challenge in the United States and Canada will be, now and for a long time, the boundary lines by which we have to fit all the data in. If we're talking about states and provinces, we have to understand we need those puzzle frames to be able to build the puzzle of the data layers by city and county. This is not something that can always be done by local governments. Everyone has their own county layer in most cases for their local administration work. But we need to have state and federal agencies step up to be able to provide not necessarily a legal binding boundary, but something that we can use for public safety work to have everything fit within it. Gaps and overlaps. If you remember the little stack plate animation I showed you where when you have a wireless call, it's going to drop and find out which PSAP A or B it's in, what are the odds that if I have a gap between those boundaries, or worse, between the counties and those boundaries, the 911 call, the X and Y that's going to come in is going to fall right between them. One of the challenges is if I can't find the right center right away, there's probably going to be a delay in getting that call. Remember, the call doesn't go to the center unless the ECRF sends it there. There'll be a delay in determining the correct 911 center. It may go to the wrong one. It may default. Could be a difference in sending the call with the caller to the 911 call taker. It could be a delay in that, but it could also be a delay in sending it to the wrong center, which dispatches someone for response that takes 45 minutes instead of 5 minutes if it was routed appropriately. That's why we have default routing. That's what it's about. So it's important we get those gaps and overlaps taken care of. Think about this. How would you feel about having over 3,000 counties figure out their own county line and working with all of their neighbors? I'm sure everybody works well together in 3,000 counties to try to come up with what a consistent, coincident line is for every angle of their county lines. It's probably not going to happen. That's why we need coordination support between states and counties. The NSGIC group, the National States Geographic Information Council, which I liaison with on behalf of NINA, understand this, and they're trying to work towards getting this done in many states. Texas has been very good about trying to work with their boundaries to get them stabilized. In Texas, we have about 75 public safety jurisdictions split between districts, home rule cities, and councils of governments or regional planning commissions. TNRIS, the Texas Natural Resource Information System, which, well, you had to go register for some of this for the URISA presentation, arbitrates, helps, or not necessarily, they're not responsible for it, but they help make people aware that they have a county line file that can be used for that on behalf of the Commission on State Emergency Communications, at least for the CODs and RPCs. So if we can get each state, I know Arkansas is good about this, many of them, to get a definition, define or point to what's a good starting place for counties and state lines, that's good. Even with Canada, we have provinces, we have the US and Canadian border, we still need those lines to line up. Here's an example. Note here that we have red and yellow lines. Our problem is going to be where we have those big overlaps with the red lines, and the yellow lines are indicating the yellow line work that what they need to line up to. So you can see you got some problems here. And that wireless call, there's a house that may be in the wrong jurisdiction. Certainly, if this line work is supposed to follow this yellow road, where this yellow line is, these houses are in the wrong place. They may get routed to the wrong center. So it's something to keep in mind. Overlaps, gaps, and something called vertice matching. This is a concept that hasn't been really embraced a lot, but we have to. When we transform, and everybody okay with the term transformation, when you run it through your ESRI system or whatever software you're using, and you're transforming from an NAD83 data, the mathematical model of your data, the globe split flat with a projected coordinate system, and you transform that to WGS84, some distortion occurs. So unless you have each of the vertices, and I have a nice graphic we didn't use here, but if you don't have each vertice lined up between adjacent polygon boundaries that are really coincident and on top of each other, when you transform data, there's a chance that that line work will get a little wonky. It'll get overlapped or gapped because you're not transforming the lines, you're transforming the vertices, the points or nodes within that data set. The lines really just connect the dots that the software does. So we have to understand some of the geometry issues. Thank God I got to take geometry twice when I was a kid, because I get it now, and it's important, and we have to bear that in mind. And that's not something that's generally discussed, but we try to bring it out in some of these presentations. The road Centerline table, we're going to go back to the data model. As we round up our discussion of Centerlines, the tables in that data model tell you, as a data architect, as you're building out your data, and all of you on this call, I don't care what data you're building or why. If you're building roads or points or parcels for appraisal districts, whatever you're building, it's probably going to have value in public safety. So it's good to be aware of some of this. In-road Centerline data, for example, I pulled the table. It's one table, but it takes 3 pages. I've got the definitions I pulled from that standard. of mandatory, conditional, and optional. These are the fields we need. The top one is discrepancy agency ID. That's who gets the report that the data is messed up, or it's wrong, or it's missing a value. And we update fields. We have all these things. And again, they're classified as M, mandatory, C, conditional, or O for optional. Most of them are conditional. If that means if you have the data, you really should include it. But the mandatory is the ones you have to have, or it's a non-starter. When we look at the next half of it, we go to the rest of that table. Again, this is one long table. I had to split it up. These are all optionals. But look at some of the optionals we're getting to. One way, speed limit, road class. Those are all optionals. So there's a lot that we could be doing. If you're running a computer-aided dispatch system, you are keenly concerned about the class of road, the one-way nature of the streets, speed limits, maybe even time of day. So there are things in a network system that may not be fully accounted for yet, but we've got a lot of the basics in the road centerline table. The road centerline table, along with all the other map layers in the data model, was originally started in 2010 when that work group started. They just completed their work in 2018. So 8 years gestation to get this out there. Now the good news is we took that long, we got to define everything in it. We defined the field names, the description, the domains, which is nice to have. What's the domain, if any, and give you examples. So that's a self-contained document that gives you examples of how it works. Let's apply it. Let's look at what you're dealing with. I don't care if you're at the Texas Education Agency. I don't care if you're working with the Historical Commission. We all got to deal with address points and maps and aerials. And Texas is phenomenally rich. Many other states too. Everybody's got aerials. When I started in this business, I know this is grandpa talk, back in the late 90s, aerials were nice to have, and they're multi-million-dollar projects. Now they're everywhere. They're in every state. So there's no reason not to be able to have some aerials, even though they may be dated. But in this example, when we're talking about address points, I've abbreviated with AP, and road centerline is abbreviated to RCL. How does it match up? You'll notice in this road, I have this 1,800 blocks of roads. Ignore this whole 1,900 block anomaly. Here's my addresses. Here's a substation. It's 1807 on Bruns Mill Road. Here's 1825, this house in the woods. Here's 1853. Now, somebody had an old settlement house back there. It was addressed 1947. That's fine. How do we deal with that? Is it a dispatchable location? What's the problem? When we're searching in the ECRF, we could probably use address points to deal with these anomalies where the house number doesn't necessarily match what the range would be. That house number, if it went to the road centerline where it should be, is way off that image. Could take us a long ways away. And if we have boundary lines, it could be a problem. So in some cases, what do? The points are nice to have, but what if you don't have points? Then maybe you need to adjust the road center lines. In this example, we've had someone that's taken the road center line for the 1900 range for that 1947. It's 1947, 1947. They've chopped it out of the range down here and moved it where it's close to the road so that you get a pretty good proximity where the points roads are. Remember, if you didn't have this point, this would give you a better approximation of where that location would be determined on the road, best reflecting that house. Does that make sense? So there are ways to do it with points. And if you don't have points, ways to do it with roads. Remember, roads are necessary for everybody for interoperability. Now, let's throw in the complexity where we have the 911 responder centers, PSAP A and PSAP B. Here's a challenge for us. Now I got another problem. Here's 1947. It's in PSAP A, but PSAP B needs to respond to it. If I'm just using points, what's the dealio here? What do I do? Some people will put a little horseshoe here and take that little orange line and hook it around and then the red line so it does fall in the right boundary. You can do that. You can also, in some cases, people will move the point where it needs to go. What the point of this whole series of images are is that what you are building, all of you who work on data, particularly NIMO data, is that you're building intelligence into it. Your job is to build data that informs the ECRF, that helps make the decision-making before the call is even sent to the call taker. So I want you to think about that as you work through some of the 911 questions you may have. Now, validation civic searches. Here's where we kind of turned upside down its head. That was a spatial aspect of it. In reality, when we're doing searches, it's all about the data. It's all about the attribution. On the right, we have the industry standard of how data is searched hierarchically, larger, smaller geography. In this case, country, state, county. These are the PIDFlow elements for how it's searched. This is a standard we use nationally. Here's an example from New York. This is an example of what you'd have as a PID-flow kind of file. You have, in this case, it's out of the state of New York. So we have country is US, state of New York, Kings County, New York, Manhattan, Morningside Heights, Broadway. Now, everything in Broadway may go to the same 911 center. So if we get down to Broadway in the search mechanism, and Broadway is a RD, we get the street name, we never need to use the address because everything from that street name goes to the same PSAP. So this search mechanism is hierarchical from largest to smallest geography. By the time we get down to the house number, we've probably exhausted everything that routes specifically. So it's not going to be very often, I would imagine, that we're going to get down to the house number. 911 GIS data stewardship, building the data is a challenge. The data model only tells us what the data has to have in it, doesn't tell us how to build it. So we have stewardship guidelines, which we've already built. Here's the code for it, NG9-1-1 with the PSAP boundaries. Tell you how to build it, what it should have, it shouldn't have, things to watch out for. Right now we have 2 work groups. I'm serving on one of them, the road Centerlines, and we have one for emergency service boundaries, fire, law, medical. That will be coming up. They just posted in 2020 the PSAP boundaries. We'll be working on these this year. Hopefully we get it done by the end of the year. And then we're going to work, it's all going into a master document. If we finish it by the end of the year, then we'll get on to site structures. So this will be your how-to cookbook of building GIS data for the 21st century. And again, you can get the first iteration, which only has PSAP boundaries covered, in NENA INF 028 version 1. Give you some examples. These are just some graphic examples of kind of creepy things we work with. So if I have a road that's going across an interstate, what about pinched roads? Are pinched roads okay? What about offset, points that are in another jurisdiction that are in a road that should be somewhere else? Or coves, all the different ways coves are done. Or do we do split roadways? Do we do roads that are on top of each other, i.e. coincident? Do we do them where they're real close to each other? Do we go 3-dimensional and try to look at them obliquely? All these things are being discussed in the stewardship work groups, in particular the road Centerline one. So when we talk about data, we talked about the polygon boundaries for counties and state lines and national lines. We talked about the roads, talked about address points, the responder boundaries. What do you think is the most important data for NG9-1 to focus on at this point?
And there's a couple of quick questions here for you, Richard, from Nick Lamontia. I think I said that right. In those agencies who are already prepping their data for next gen, do you have any idea about how many are prepping it themselves as opposed to going out and selecting vendors to validate it for them?
Great question. We've had a lot, and I've worked in a lot of the states around the country. Again, it's only a small sample that I can speak to. Many of them try to do it on their own if they have, 1 or 2 staff that have GIS expertise. Many PSAPs, particularly in rural areas, don't, or they have part-timers. They just can't take that on. So they will go out for a contract to have the data evaluated, and after evaluation, maybe do some base remediation so they can take it over from there. What's happening as well is some people are saying, okay, I don't want to be responsible for calls misrouting or for data not working or to maintain it at 2 in the morning if my GIS server goes out. So in many cases, they're considering long-term contracts. I would say, if anything, the people that are doing the work will take the existing data, like you see in the poll here, the roads, as a critical layer. They've already got it for their mapped area, their CAD. They'll try to use it as is, as long as they have the fields necessary in it. They may have somebody work it for them, or they'll go to sessions like this, or to state seminars or webinars to try to get the information. But the key is understanding what needs to be done and to make a decision from there. So it's kind of, if I had to put a percentage, I'd say about 60–70% are doing it on their own. I'd say another 20% or so get jump-started. They say, hey, please check our data, tell us where all the problems are, and give it back, and we'll take it from there. And a small percentage, which is growing across the country, are saying, and I don't want to fool with this, I don't want the liability, you guys do it, and I'll just contract with you. It really depends.
And another question from Ramon, would you suggest TENRIS assist with the arbitration on this, or do they have an authoritative source for county boundaries? Yeah,
I can't, and Ramon, I brought that up with the TENRIS leadership. We've talked about this over the years very much. When the Commission on State Emergency Communications said, we are not going to get into that dogfight on that, we would prefer TENRIS to make that available. TENRIS has to make that, if it's dealing with the boundaries that the state understands, I believe they will provide that it doesn't cost anything, but they won't have responsibility for it because, as you know, it's as good as it was when it was last surveyed. Every county has not been surveyed of recent time, and we have rivers and waterways that are very common county boundary lines. They move. So what it comes down to is really two counties, let's say they're adjacent to each other, negotiating what they want to use for their 911 work and make sure they're using the same consistent boundary that's, as I said, hopefully in a coincidental line work and vertice to vertice alignment. Does that help? But yeah, Tennis is where I would go to ask for that. I know Felicia Ortiz was there. We had Richard, also the state GIO, and some other people. We can provide contacts if necessary after this. Ali MSAG today and tomorrow. This is short, a couple slides on this. One thing that someone often in business, you say a number, people love it, particularly program administrators who don't work in GIS. And I think it was 2009, NENA 71501, a document was brought out. It wasn't a standard, it was a informational document. That's kind of like, hey, here's some ideas you might want to take to heart. And in this document, it said, how do I synchronize my GIS data with my old data, my Ali MSAG, so I don't leave anything behind when I move over into a GIS data only world. That's great, but they set a percentage, we want 98% or better matching. All the names in this document, NENA 71501, great document on how to synchronize, but it was done before there was a data model. It was done before all these other next generation standards and requirements documents came out. So it was a product of pre-planning, but people hung on to that. One of the things I would say that if you're going to consider this, that think about the work that would be involved with this. Here's an example. This comes straight from that document. On the left is what the data would look like, that little table. If the way it would look like today, North Elm Street, you see the street name, the suffix, Grand W Parkway. Well, in that document for synchronization, it says you need to go back and clean up your Ali and MSAG before you even do compares. If you do that, what's going to happen is you're going to have to change everything in red to standardize it with USPS, that's US Postal Service Publication 28, so that it matches what you need to have in your GIS data on the right before you even do anything else. So there's a lot of work there. This is why I called your attention what we said at the beginning. If 10% or less of your calls are landline, and you know the boundary lines for PSAPs are probably the most important because 90% of your calls are going in them, and nobody's really putting all the time into that across the country. How much time do you want to put into synchronizing these two databases and then to dispose or discard of your Ali MSAG because your Centerlines are good enough? We'll give you some examples of what to check on this, but you got to think about your work with consultants, work with people who know, go to the conferences and figure it out. What makes this even more of something you need to consider is that in the ECRF, if you look at something like a Cascade logic, why do you need to dispose of any of your data? One of the things you can do with our technology today, ours as an industry, all my colleagues at all the different companies I've worked with, as well as my own company here, we look at how we can do this as a cascade approach. You can have your address points and your road extent lines and your MSAG all at the same time and have the search mechanism to where it'll search one if it can't find the specific address in the APs because it just got added to your database. Then it can go to the road center line. So it can't find that. Well, maybe it's in your MSAG because even the roads are new in the subdivision. The plat hasn't been completed yet by the mapping department. Well, that's fine. We want to avoid that default routing at the bottom. That's the thing. So you have software today that can handle all of these. Keep that in mind. Given that you can use your data as is, given you can search multiple layers, and given that, you know, it's important, how do you feel about basic GIS availability? One of the things we want to do is not make people afraid, but make them understand this is a work in progress. Don't be afraid of it. We want you to understand you can start with what you've got. There's mechanisms for correction. There's discrepancy process will be put in place, and everybody's in the same bucket. I've worked with the largest cities of millions of people, Houston or otherwise. I work with the smallest communities of 10,000 people or 5,000 people. We all have the same problem. We got to get these systems implemented and figure out how to correct problems as we go. So you're more confident or less confident?
Seems like we have, majority is more confident about it.
By the way, I'm in the undecided batch for those of you who have voted undecided. Well, let's keep going, less confident. We'll see if we get you a little more. Because I'm afraid the next thing I'm going to tell you is both helpful, and then the last segment, maybe not so much. out of this entire session, I think this is the most important diagram of what I can implore you to do. I've explained this to people at states all over the country. I've explained this to national organizations. You can start getting your move to next generation 9-1. Remember that diagram from Nina with all the boxes and all the little widgets in it, stuff we didn't even talk about? You can work on all of that, have your IT guys work on it, your service providers, everybody. But as long as you've got an MSAG and those polygon boundaries, you're good, because that's going to give you, the MSAG will give you the ability to look up civic locations, that's the 105 Main Street, what have you, and the responders for the locations. And the PSAP boundary handles the geodetic in concert with the responders that's already in the MSAG. So those two right there will get you what we call a functional LVF and ECRF. That's it. You can start now. You probably already got it now. However, most people say, well, I know I need to have roads. I know I need to have responders, fire, law, medical, and others. Well, let's get on that. Well, if you get the roads and the responder polygons in good shape, you probably don't need the MSAG at that point. So then you'll only wind up with roads, responders, and PSAP polygons. That is an I3 ECRF. That's what that STA010, that 800-pound gorilla looks like. All those pages, okay? Then address points. Address points are an enhancement. Yes, they're nice to have. I've known entire cities that have built their entire database on address points and didn't build any roads. We've now had to go back and build roads because you have to have it for interoperability. And it's a good safety catch, a safety net for you. So when you look at this, make sure you look at the notes on the side where I've tried to articulate what you've got that matches up. This is as simple as it can be on how you want to move forward. But if you want a detailed plan, here's what I'd suggest. And again, this is just my suggestion. I've been doing this for a while. I was a GIS guy in government for about from 95 to 2004. I feel your pain. I've tried to integrate cities, counties, cutouts, working with county lines, different pieces of software from some goldie oldies like Atlas GIS, Map Info, GeoMedia, to all, of course, all the fine Esri products, to AutoCAD. So I get it. We've got challenges. But what I would recommend you do is start with the PSAP boundaries. Everything's got to fit into that puzzle frame. And then work with your neighbors to make sure your PSAP boundaries match. After that, relatively simple. Then you need to make sure your responders fall in your PSAP boundaries. And again, we won't get into interlocal agreements and overlaps and who's got control of what community because there's no way to get into it from a road. That's a whole nother session. But we got to deal with road center lines, site structures. This is the order in which I'd probably work it if it was up to me. The second thing is, once you've got those layers that match the data model, that's the first thing, get the schemas right. Then you're going to make sure you need to have global unique IDs. Huge challenge. How do we make sure a global unique ID is global unique across the United States? Because data can go, well, in NextGen just about anywhere. Develop a URI, that's a universal resource identifier for taxonomy and provision of all GIS data sets. Those URIs are basically URLs. They're the paths to the PSAP, and they're required for all the PSAP boundaries. So the whole point of identifying the point or road within a PSAP boundary is so that PSAP boundary URI can send it to the right PSAP. That's what it's about. So you got to work that out. You can't do it on your own. You got to work with your service providers. It's not difficult, but you do have to add that attribute field, and that's in the data model. And then you check the attribution and the geometry to make sure you don't have anything goofball in there that's not consistent. That's your cleanup work. And remember, you're thinking about the ECRF work. How are you trying to provide information for ECRF? Then, and only then, after you clean up your data, you've got the base schema right, you're interoperable, capable, then you go back and say, you know, let me look at my MSAG and ALI. Let me make sure I at least cover all the names of my MSAG, and all my ALI records should at least have one address. You know, every unique ALI address should have at least one address point which matches to it in my GIS. You do that, you're good. In fact, there's a cheat. Number 3 there, if you run your ALI records against your road center lines, remember, even if you just have road center lines, that's probably a good indicator that you're going to be able to route calls coming out of your existing 911 people calls in your area if you're checking those ALI records in your ALI database today. So could you make a work plan today to prepare GIS data while you're doing your regular job? Given what you know now, and you can refer to these, you'll have this in your hands. You have some, this isn't real rocket science on some of it. We're just trying to give you that low bar to jump over. That's what we're after. So I'm curious if this is helping. And we'll do the last section next. Dylan, how are we doing on questions?
Questions are good. I think there was one we missed from Walter Kent Cursor, and he was asking about what about the arrival points on the Centerline? I guess how does that play in?
Yeah, if you're talking about driveways, and we're talking about address points, there's a site structure address point document, which is fantastic. I work co-chair on that. I mean, if you were just given an address, how many pages do you think it would take to write up how to place a dot on a map? It took us about 59, I think nearly 2 years and 120 people. It's pretty amazing, but it talks about, do you put points on the structures themselves? Do you put them at the driveways? If I'm getting you right, it goes through all the different methodologies, and there's no sound answer. It really goes back to how you want to represent it in your ECRF for call routing. We're not talking about CAD. You can always have another layer that has points or other things that the computer dispatch needs for those operations. So just keep that in mind. Yeah, so good. So at least there's some value here. And yeah, there's a lot to take in, so you may not have all the answers. On the horizon. Okay, let's talk about the rocket science stuff. This was the basis. This is what we have to do. This is what every county around the United States has to deal with, every city, every state. And it is happening. It's happening now. But you know what? Most of these major systems have not gone online. My fear, when they start going online, how do we keep it out of the news? How do we make sure this stuff works? And you know what the answer is? Having good GIS data maintenance practices and recovery capabilities. How do you deal with problems? How do you have backups? You know, it's funny, we looked at some of the standards in the industry, you know, many of them didn't even talk about backups. You know, I know in this age of, where you're having, hijacked malware where somebody can take over your system and hold for, these ransomware systems, that's bad. We're now tackling it. Security is a big problem, but have a backup, somebody who knows GIS, how to reload a server, how to reload a geodatabase or shapefiles or related tables, deal with all that. That's a discipline. That's what you folks are training and learning on who work in the GIS field. That's an incredibly valuable skill. You can't buy that skill. You have to learn it. You have to practice with it. So for those who are interested in GIS and 911, there's always going to be a world, and like I said at the beginning of today, you may need more people in 24/7, 365 role than we ever thought. The FCC came up in 2015 with a requirement working with National Emergency Number Association, we see up here, NANA, APCO, the 4 major commercial mobile radio service providers, that's like AT&T and Verizon and others, that we need to have better indoor and outdoor X and Y, the location requirements. We're kind of working on that. We need to have some kind of a vertical determination for people in buildings, particularly in downtown areas. We need to have a dispatchable location. We have building, unit, floor, and room. And we need something called the NEAD, the National Emergency Address Database, which has every Wi-Fi and Bluetooth device there is in a single database, queryable. Unfortunately, recently, it was deemed not feasible to have a dispatchable location. Technologically, if you don't have a database structure that allows you to input the building, unit, room, floor, you can't deliver that. So that's kind of out of the running for right now. Worse, the NEAD, that project was started up. We got into it about a year, and they realized that wasn't going to work as well. And a lot of that had to do with people who didn't want to give their proprietary information up. It was almost impossible to manage. When you think of every exit sign and light bulb that could have a Bluetooth device, it really got out of hand. So that leaves us back with Z-value. So in October last year, 2019, on the 29th, the FCC released their requirements. If we're going to do this Z-value, we need to have it 3 meters or less. And that's for 80% of the 911 calls. Well, guess what? WGS 84 doesn't do that for us. Ramon, this is back to what you said. That NAPGD 2022, that new datum that we're all going to be hearing more about in the next year or two, when it comes out, it will achieve 3 meters or less. And we'll have to talk about conversion at that time. As a reminder, we're not done with that. This is our diagram. We've talked about ECRF, the key thing we populate. But guess what? There's more. Discrepancy reporting, we have to have a service that tells you where problems are occurring in your system or with data. We have a mapping data service, which is essentially a Google-type map, which allows you to see a map display at any 911 center, anywhere in the U.S., for any land in the U.S. if you get an out-of-region call. I got a co-chair that I work with some colleagues. That'll be a challenge. The geocode service we talked about, we won't get into that today. That's basically taking any civic location and geocoding is instantly, if possible. There's the MSAG conversion service. How do I take MSAG names from older sites and convert them into the new next-gen format that we talked about, and vice versa, because not every site can convert at the same time, but we're going to exchange data. There's policy routing functions. How do I deal with routing if it says, yeah, you go to this PSAP, oh, except after 4 because they close at 4. Then it's got to go to county. So we have to come up with how policy rules work and policy routing function itself. Then there's additional data repositories. What if you need other map data? I mean, you've heard of Rapid SOS and other companies that can give you pre-positioned, pre-planned databases which have medical information. It has maybe other instructions about the nature of the area, whatever. You can have all kinds of additional data sets. So all these may involve GIS data to one extent or another, and we won't go over them today. The last thing I want to leave you with is what's over the horizon. Truly, this is the next generation. We just touched on dispatchable location, which is the granularity, the sub-addressing, which is another way to refer to it, a building floor unit room. We are working in another area on CAD database interoperability. We're talking about the GIS. I know I'm involved in trying to see if we get initiative on the national standard for that, so that all the data gets delivered out of the 911 system today to any site that's standardized by NG9-1 standards can also feed a CAD. Now, the CAD companies, of course, have to sign on, so we'll need to get their buy-in, get them skin in the game, so we want to do that. Bear in mind that 3D is a huge thing, and it's not like going to a movie theater with glasses. When we talk 3D, we're talking about dealing with elevation. Any of you who played anything from Doom to Minecraft, you get the oblique perspective of looking at maps. Do we now need to look at the oblique nature of maps from the human perspective, some kind of ergonomic way to approach it in the 911 centers, and building data? We're challenging that. Internet of Things, we already have situations where people want their devices that talk. You may want have it discuss something with you, or your TV or your refrigerator. You may want to crowdsource locations, find out where you are if you're unconscious. So if Siri's going to help you out, that's part of it. AI. We've seen a lot of the protests and issues going on this week. We're not going to discuss practical concerns with police departments or funding, but what NextGen can provide us the ability to have other layers. We're not just restricted to fire, law, and medical. We could put mental health responders. We could put social service responders. We could put anything in those layers. That's the key for the ECRF. It can search any number of layers and send any number of recommended responders to the call taker to then decide who to send. So even in the midst of all the turmoil the country's going through, even with COVID, you could have all kinds of response recommendations sent to the call takers. That's powerful, and we can't have that in the old world, only in NextGen. Drones in real time, cloud-based solutions, everybody's going to cloud-based. There's another national standard underway to maybe standardize some of the concerns with that. Third-party public safety apps where, like, find your nearest defibrillator or doc on a phone, who's the nearest medically trained person, and many more. So for those of you who are interested in participating, NINA itself, there's a website. I've got it here. You can go in, select communities on the webpage. Just type NINA.com. Go in and find the Data Management Committee, and then click on Join a Work Group if you like one. You'll see there are always new work groups, and we can talk about all that stuff. Last poll question. I'll leave it to you, sir, if you want to ask. Dylan?
It is in progress as we speak, and there's a couple more questions that came in. One's from Heather Studley. Does anyone have a resource to translating this kind of checklist and into an ROI to support all of the expansion that you know of?
No, but there's a transition work group for NINA that's trying to show how you can transition over. The best bet is take some of the information here, look online. If you work with some of the private sector companies, each one's probably going to have a different take on how you might want to prepare. It's not easy going forward. I've tried to give you some very general information, but if you have questions, you can go through URISA. URISA can pass them on to me, and I'll try to give some generic responses. Dylan, that might help that everybody can benefit from if you got any questions after the fact.
Sure. It looks like pretty much everybody came away with this learning something about the future of 911 technology. So that's great.
Well, we appreciate everybody attending. We appreciate you listening into this. I hope you're able to take away a little more. Again, we could spend hours talking about some of these subtopics, but we really want to give you a sense of the flavor. And anybody who needs a job in 911 public safety, let me tell you, it's growing. You won't hear about it on the news, but you can't turn the entire nation, 3,000 plus counties, out on their own in GIS without having some expertise. So think of it that way. On behalf of myself, I appreciate the opportunity that URISA afforded me to let me speak about public safety. And again, if you have any questions, Dylan, feel free, you and Brian, Ollie, all of you can just compile whatever you need and I can get you back some responses.
Sure, we definitely will. And Richard, I really want to thank you for taking the time today to come and present all of this information. I know it was a lot for people like myself who came into this not knowing too much about NextGen 911, but I'm really glad to have somebody in the profession like you to come and share your thoughts and feelings about it all and present it in a way that we could always go back and use that as somewhat of a blueprint or a schematic to help build this for the future. So thank you. Really appreciate it.
You bet. And again, it's just, this is one person's opinion. As with any good doctor, I suggest you get a second opinion or third or fourth. Research and understanding this, what you're going to take away, folks, is something to give you the tools to understand the basics so you can go ask more questions before your jurisdiction acquires services or goods or whatever. It's just basic education on this.
And yeah, there's a lot of people that were saying, thank you, great job, good presentation. And hopefully, Richard, we can have you back down the road and see what's happened since since everybody's starting to work more together
every year
same goal.
Changes. You bet.
But thanks again, and thanks everybody who came and showed up today. Please, just last reminder, if you're still in here, change your name to your first and last name, and we will get those PDH certs out to you. And Richard, I hope you have a great rest of your week. And thank you again.
You guys too. Thank you. You bet. Thank you.